transcending national boundaries, you can end up paying 10% of the overall, amount of money or more, I'm not quite sure, that you're trying to, which is crazy, and it can take up to a week for a check to clear. Bitcoin solves that by making it completely decentralized, so it goes straight from one person to the other, no central government, no central banking system involved. They are completely disintermediated. That means that the cost of a per transaction is almost zero. It almost is instantaneous in theory.
And that one as well.
Exactly, but that's what, that is the objective, that's the problem they're trying to solve, just completely rethinking the entire concept of global currency, how it works. And then with regards to the internet, instead of currency and money, you're talking about data and transactions. So money transactions and things communicating and contracts, they're no different, they work in exactly the same way, right? Okay.
So, this is what we're trying to do. We're trying to transfer money. One of the problems you might have is overspending. So if Alice tries to spend the same money twice, we don't know what's happened in this situation because the money, there isn't that money to spend. You might get blacklisting. So when Visa decides that they're not going to allow certain people to have money, Alice tries to send money to Bob, and the bank says, no, you're not allowed to do that. People might try and alter the past. So Alice spends 50 bitcoins to Bob, and then later on she goes, actually, that was only 5. Can I keep 195 instead of 150? So these are the kinds of attacks that people would do on financial systems. So when you want a decentralized ledger, you want it to be append only. So you can only add transactions, you can't change what's happened. You want to make sure it all adds up. So any coins in it can only be spent once. You want to make sure there's no trusted party who could blacklist addresses, demand fees, go offline, be a single point of failure, and you want it to be resistant to hacking. That's a quick sense of the design principles for a currency. And the blockchain is the way that Bitcoin does that. You'll find there are other blockchains out there, and it's a way to group up transactions into blocks to say, this coin was sent to this person who sends it here, it goes into someone's wallet, and then gets transferred to someone else. The thing that makes it a chain is that each of these blocks has a whole bunch of data in and a hash of the data. So that's the thing that says if you change anything in here, the number changes. Let's get the transactions. And each block has a hash of the previous one. So you have all of this data in here. This block says, right, I've got the new data, but I've also got a number that perfectly identifies the data in the previous block. And you keep building those on top of each other as a chain. And by doing that, it means that no one can go back and say, I didn't say that then, I said something else. Because you've got all of these blocks that have come afterwards that are built on top of that data, so nothing previous can be changed without changing all of the blocks in front of it. And that's a big part of what gives Bitcoin its security. So it's making a hash of the previous data, and then each time around you collect up a bunch of new transactions, you put them into a block, you add in the hash of the previous one, you do this magic of finding a special number that gives you a hash of your block with a certain structure that you have to do at random, and that's the proof of work that we saw happening. And you just keep adding these in, and that's it. That's the blockchain.
It's kind of, I suppose it's kind of like a sequence of truth. And once that agreement, that transaction has been complete between two machines or two humans, the blockchain seals it. And it's completely uncrackable in theory and immutable. So it's a little bit like a friend of yours and you kind of, okay, 50 quid, you owe me 50 quid if I get the round of beers, right? And you promise to pay me next week, okay? Now, what's to say next week, you go, you renege on the deal and you say, I never said that, I never owed you 50 quid. Even if you write an IOU, then what's to say that you either dispose of the IOU or actually meddle with it in some way and go, no, it's never 50 quid, look, it's 30 quid. I can't read the writing. This ensures that once that transaction, you've agreed to pay 50 quid, here are the terms, it's locked into the blockchain for all to see, so it can never ever be amended, changed in any way, shape or form. So in theory, it eradicates any possibility to change the truth or adapt the future, the past in any way to prevent future fraud. And that is what makes, again, this game-changing, because it could theoretically eradicate fraud. And it's not just financial fraud, it's records. So it could do away with any kind of document fraud like passports, identity, and I think a lot of governments are transitioning into it. I think I'm done now. So, sorry, Dave, you're just getting going, right? There's more to come, isn't there?
Yeah, there's lots more.
So, just go for it. Quick question, then poor Dave needs to get his sort of rhythm back, and then we'll do kind of serious Q&A as a panel at the end if that works. So go for it real quick.
So I was just wondering about the example that you mentioned now. So I owe you £50, someone might want to change it to £30 of it. That information is stored in the blockchain and you can't change it, which makes it secure against fraud. But where's that information actually stored?
It's a distributed system broken into nodes. Exactly, and that's
Yes.
the beauty of it. There's no central
So
server.
it's a whole network of machines. Anyone can join in and become a Bitcoin node. And then you start seeing all of the blocks that everyone tries to add to the chain. And part of what Bitcoin does is make sure that everyone has consensus about what the correct chain is. And part of that is one of the nodes will gather up some transactions, do this hashing thing, and then they send it out to all of the other nodes in the network. So anyone can have a list of all those transactions.
But therein lies the limitation,
If
right?
you want to, you can go and download it now. It's about 60 gigabytes, if I remember right. And you can then join in and start seeing all the transactions as they come through.
So it's turning into a bit of a double act, and I will shut my face in a moment, but just this is part of the limitation that every person who's participating in this distributed, consensus-based banking system, if you like, gets a record of the ledger. Anyone can actually see every single transaction because it's immediately, in theory, replicated on the hard drives of every single computer or node that's participating. And in order to give a little bit of your processing power, or quite a lot in some cases, to the cause, you are rewarded, because it costs you energy and money to host a Bitcoin node, you are given Bitcoins in return in payment. Do you understand? It's your incentive to keep a computer or a massive server farm of computers connected at all times, enabling these transactions to take place and storing a complete copy of the entire global ledger. And the problem is that every person who uses it, this ledger is getting bigger and bigger and bigger, and it's being replicated on every single node, every single computer, every single server. And so people are starting to run out of processing power and storage space, and this thing is too bloated, and that's why the whole system is starting to grind to a halt, because they're trying to replicate the truth, the ledger, across a global, decentralized supercomputer, essentially, made up of all these little nodes hosting this data and replicating it. And it's not really scalable because it's becoming too big and clunky. And that's why we've actually got to start rethinking the blockchain as a concept and look at other alternatives.
If you want, I can arrange to come back at some time and do a slightly more spaced out blockchain intro, because it's kind of hard to get it in these little sound bites. But one of the things I was getting to is it's really hard work to do this stuff. It takes a lot of energy and resources, so you have to figure out if it's worth it for a particular project. These are kind of all the things you should need if you think you want a blockchain. So in absence of trust, you want to have multiple people writing to your database. You want to have disintermediation. You want to have a choice of people who are checking that things are okay. You want to have interaction between the transactions. And if you don't have all of these, then the chances are you're probably better off using a relational database or an NoSQL database, or one of the more traditional tried and true ways of managing large amounts of data. So there's certain properties that are really important for blockchains that you often don't need in other places. Does anyone know what this is?
Cowrie shell or something?
Pretty close, yeah, same idea.
So it's a coin.
It's a coin. This is a ray coin used on the Yap Islands in the Pacific. They're money. They're big. They're like this big. So when you have money that's that big, it doesn't make sense to actually carry it around and go down to the shops and then get your change, which is slightly smaller. So they don't actually move the stones. They have an oral history about who owns particular stones. They still use them for transactions, but they never have to actually move them around.
They did actually do it once, actually. Well, there was a reported case where someone was transporting